Good afternoon, and welcome to our first virtual tour. My name is Joe McDonald, and I'm the Vice President of Sales for Jasper Engines and Transmissions. On behalf of our 2,300 associates, we want to thank you for attending this tour. It's been a difficult couple years for all of us, and hopefully we're getting back on track and can get the supply chain going again. I want to share some things before we start the tour and just share where we're at with some of the supply chain issues where I know a lot of the questions are coming from. Again, on behalf of the 2,300 associates, we are trying everything we can to get the supply chain going and get the products that we need. We appreciate your patience. We understand it's been frustrating at times, calling in some of our hold times and our lead times, and we're very sorry for that. However, I want to express we are trying our best to continue to bring the service that we're used to bringing all of our great customers. When you look at the industry as a whole, we're all very blessed. It's growing. We're truly in a great position to take advantage of that growth, and we're going to continue to do that. Doug Bobble, our chairman, has said it best. We're living in a triage situation right now, and we're doing everything we can to put out the fires and to continue to give great customer service. Couple housekeeping pieces for today. You can type questions in the comment section, and in between each segment, I will try to answer a couple of them if I'm able to. For any questions I don't get to today, we'll make sure we follow up and get you the correct answers. Please leave your business name, your name, and of course the question in the comment section so we can follow up with you after the virtual tour in case we don't get to it today. We're going to start off with our gas engine portion and the disassembly segment. Scott Hoffman oversees this division for us, and we'll ask Scott to take it from here.
Here is an example of one of our many disassembly cells we have in gas engine remanufacturing. This group really starts the ball for everything that involves remanufacturing of a gasoline engine. It starts with the basic tear down of the outer shell of this engine. It's going to start with any remaining accessories and then moving on to those critical tinware items that we're going to need. And as we begin to crack through the shell of this engine, we'll go through in a bit of an inspection process, and we're going to identify this unit, cylinder heads, engine casting, block castings, even crankshaft. We want to make sure that all those components are going to match up to our bill of material so the finished product going out has all the major components that are going to be necessary. Once we get through some of that initial teardown, it'll go through head disassembly. We'll take all the pistons out. Everything will get down to its bare shells so that we can start it through a cleaning process a little bit further down the line. It is disassembly, but the one thing to remember here is how critical is that when you're talking about that engine. This really sets the stage for everything necessary for us to have success through this process. Okay, what we're standing in front of here is our bake ovens. What these are really set up to do is take care of any of our deep cleaning of our cast iron material. So in essence, your cylinder heads, your engine blocks, and even some of the steel tinware that could support this type of cleaning. What's going to happen is it's going to go into this process typically overnight. Once we lock down, shut the doors, we set up the process, and these gas furnaces fire up to temperatures of 1,800 degrees while we're sustaining temperatures of around 1,100 degrees for up to 8 hours. What that does is it really creates almost like an oxidation. It'll cook off any oils, it'll cook gasket material, and really make this simplified process for cleaning. Okay, we're now in the repair areas. So the block has been torn down, everything has been disassembled. Your major cast iron castings have gone into the bake oven. Those are ready to be cleaned in this area, and then any aluminum or critical tinware is also ready to be cleaned at this point. If it's cast iron and it's come out of the oven, it's going to go into a steel shop machine where we're using those micro steel BBs to clean that remaining ash and gasket and just blow all of that soot that was created in the baking process off and give that casting a light new appearance. Any of the aluminum is going to go into plastic blast beading in a cabinet where we're going to blast all of that off. And then we also have a soda-based material that allows us to clean some real critical areas that are going to be a little bit more delicate and can't handle the aggressiveness of plastic. All of your surfaces are being maintained with that without any jeopardizing of gasket surfaces. Once all of that cleaning is finished, we then move into the actual inspection repair process of those castings and tinware. We're inspecting bolt hole condition, repairing as needed. That includes spark plug holes. Once all of that's finished, we go through some final inspections to really determine what machining is going to be required for those major castings. If it's a cylinder head, is it going to be a cam bore? Valve seat machining, milling is going to be up next. If it's a block, deck surfaces, main saddle condition, and then cylinder condition as well.
Thank you, Scott. Next, we're going to go over to the crank, cam, and rod reman section. But before we do that, he mentioned a couple of things in there on this disassembly and cleaning piece. Really sets us up for success, and it's so true. Many of you that have actually been here in person, we get comments all the time, the cleanliness of our facility, and that really starts with these cores coming in, disassembling, cleaning them. And it saves time as we go down the line, as you'll see, to make sure we don't have any issues from this department that carry over from there. It's no different. We don't have a solid foundation on the product. It's really going to be a weak product at the end. So we take a lot of pride in that portion of the remanufacturing process. And Scott did a good job explaining it. So we'll go into that crank, cam, and rod section now.
The area behind me is the crankshaft division. What we have here is the team is going to make sure this crank meets our standards and is available to be remanufactured. So they're going to go through, they're going to inspect it for any dirt after it's been cleaned, and they're going to check it for straightness or any damage that would disqualify it from the remanufacturing process. Once it's gone through that inspection, it's going to go into either a grind process or a polishing process based on its condition. If it goes to a grinder, we have the ability to grind the main journals as well as the rod journals. Once those are ground to specs, all cranks will go to the polishing process where we use a micro finish tape to achieve that final RA result. And the great thing about these, they're all ground to the same size. So you're not going to have any mixed bearing sets in here as we go through our process. Now we find ourselves in the camshaft department. What's going to take place here is we're going to start with that inspection process. Again, the camshaft is already going to be clean. So now we're going to go through a part casting number validation to make sure that we've got the right part. So all the lobe and duration is exactly what needs to be going back into that engine. We'll check it for straightness and any damage that may disqualify it from the remanufacturing process. After that, we'll go over to our grinders. And if we find out that we've got any kind of main situation where the journals need to be built up, we have the ability to do spray welding. So we'll pre-grind that, spray weld, bring it back in, and then grind it down to our final specifications to meet our tight tolerances. Once the main bores of the camshaft have been handled and taken care of correctly, we can then move on to any lobe needs that may have to happen. Depending on your type of engine, we have the ability to grind your lobes, so we can clean those up and repair those back to like new condition as well. After all of that grinding been finished, we then move on to the polisher. We're going to go through the polisher on all of these to give it one good final surface finish, make sure that everything in there is in check and we've got the right finish to do the right thing with your lifters and maintain proper oil clearances. Okay, we now find ourselves in the connecting rod department. We're going to go through this process just like we would any other one. We're going to make sure that this component is capable to be qualified by us. That starts with inspection. We're going to make sure it's clean and straight. We've got a great system to be able to qualify that bend and twist to make sure that you get a good connecting rod every time. Once it's been through the qualification process, it's going to go to a CNC machine where we may bore it out and put a new bushing in and repair the small bore of that, or we'll go and remanufacture the big bore of that connecting rod as well. So much like a dial bore gauge in a cylinder, we have that tool that's going to be able to check that for any kind of taper, out of round condition on that big bore. So we're making sure we have a good condition to go back to that connecting rod matched up with that crankshaft.
Thank you, Scott. So a couple of things I just want to reiterate that he said there. The RA finish on the cam and crank are obviously very, very important. And again, when you talk about the foundational pieces, the internal parts of the engine, these parts are critical. A lot of times for the lobe taper, to get the correct lobe taper, we'll actually bring new cams in and put them into our machining process, again, for that quality control of that product. We all know we've gotten things out of the box that haven't been what we wanted. And again, we experience those things as well. And then on the rod piece of it, you saw some of the programming. It's really taking that chance of making that human error out of the equation, and we continue to do that throughout the plant. You'll see some more of that upcoming, and some new products out there and new machinery that we're excited to share in the upcoming months as well. Next, we're going to go over to the block and head machining section of it. So take it back away, Scott.
Okay, we're now in a block machining cell. So really 3 major aspects happen in block machining. We're going to bore the cylinders, hone the cylinders, and mill the deck surface. So that first starts with boring of the cylinders. As we bore those, we're going to bore based on damage to that, based on piston sizes available. Keep in mind, we never mix piston sizes in our engine block, so if we're going to overbore that block, it's going to be one size for all cylinders. Then we're going to move on to torque plate honing. All of our units get that torque plate put on that replicates the cylinder head, so we get proper distortion of that cylinder for final geometry of that cylinder. Moves to honing, really dials in our taper and out of round, as most of you are very familiar with. After the bore and hone has been completed, we move on to the milling process. We're going to mill that deck surface to proper RZ finish based on your head gasket design. 50 to 150 for an MLS, 100 to 300 for any graphite coated gaskets we're going to be dealing with. After that, we're going to make sure that that deck height is in proper specifications after milling so that we can maintain proper compression ratio. Okay, now here in the head machining cell, that clean cylinder head is going to come to us. All the bowl holes are already repaired. The valve guides have been taken care of. It's going to move into a milling process where we're going to machine that deck surface and provide proper surface finish based on your head gasket. With us now is Giselle. She's a team leader in our head machining cell. She's going to talk to us a little bit more about the details of cutting a valve seat.
Once the head is retrieved, we lock it into the machine's cradle, and then from there we level the head and assemble all the tooling for it. This ensures we get good concentricity, which is a quality key point that we track on every single unit, and the specifications of it will depend on the unit we are doing at that time. Concentricity is the roundness of the seat to the guide at that moment, and so we meet whatever criteria is there for us.
Once all of that machining's been done, it'll move down the line inside of this cell and go right into head assembly. So we're going to install the valves. We're going to install the valve seals, qualified valve springs if they meet our criteria, the retainers, and then keepers. Once that's all completed, here we're in an overhead cam cell. So the camshaft's going to be installed here with the rockers and the lifters. All valve lash is going to be validated. Any freeze plugs, any oil line plugs will also be torqued in at this station. Once that cylinder head is built, we put it through a vacuum test. What we'll do there is we will check each cylinder vacuum to make sure that those valves are sealed correctly. So that's going to match up with the machining process that was done to try to maintain good concentricity. The vacuum check is really nothing more than a second confirmation that we have a proper seal from that valve to the seat.
Thank you, Scott. So a couple pieces there. And again, just a reminder, if you've got any question, just put it into the chat section of the Zoom meeting. It doesn't have to be related to what you're seeing. It could be on anything related to Jasper. And I will try to answer that. A couple pieces, just to reiterate there. When you're looking at the surface finishes, the RZ finishes, again, very critical for the quality of the engine before we even start assembly. On the head machining, you saw the SERDI machine. Most of you are familiar with the ability that machine has. We've added a MISAC machine that allows us to put more heads and have more productivity. And that has really helped us increase availability, believe it or not, even in today's lead times. So we're continuing to reinvest in the machinery to try to be more lean and keep quality at a very high level. And again, on the final assembly, we are live run testing 99% of all popular complete engines. And again, that is done on that natural gas for us to check those levels, compression, oil pressure, vacuum, and those things as well. All right, we're going to move over to the transmission side of the house, and we'll have Luke Bobble take this portion.
Hey guys, this is our core warehouse. So here at Power Drive, we store our own core for the products that we're doing in this building. So all of our cores originate out of Crawford County. Then we send up shuttle trucks throughout the day to replenish our core that we have here in this building. Our pods will then produce a unit and they'll send down their next core tag to this warehouse. We'll pick it off of the shelf and then they'll run it up through our initial core disassembly and cleaning area. And that's the next area that I'll show you. So our next process that we have here is our initial cleaning of that core once it comes from the warehouse. So when that core comes up, we're going to separate the converter from the core transmission itself, because those go to two separate areas, our converter department and then the pod to be remanufactured. So what you'll see here is we'll separate those out. They'll get their tag. They'll marry back together at the end, and we'll do that initial cleaning to get all the crud off that unit whenever it comes here to us. So we're here in JCC, which stands for Jasper Certified Components. So along with getting remanufactured units through our building, we also buy up core so that we can salvage our own parts. So here in JCC, we'll salvage a lot of things like our planets. We'll go through and we'll check all of the gears inside those planets, and we'll put together different gear sets to make a complete planet. We also will bring in core and tear them down for other unique parts that we are not able to find in the aftermarket, so that we can make sure that we're getting you the best product. This is PDM, Power Drive Machining. Machining is a huge aspect of our business in the remanufacturing world. We machine a lot of the components that we send out on our remanufactured units, whether that be cases, drums, pistons. A lot of that comes through this area. We'll also find a lot of our parts that we buy new are still not up to our specification, so we'll go through and machine those as well. As we continue to look for ways to remanufacture products and salvage those items, we'll come up with different processes here in PDM to make them last long out in the field.
All right, thank you, Luke. So on the core warehouse piece you mentioned there, obviously with cores right now, we're getting them back here. We're starting to get overloaded with cores, but some of the harder to find cores have been difficult. So we sent an email out, had a social media blast last week, and we're able to find a bunch of cores that we really needed. You're going to continue to see us reach out for that. With Luke talking about the core piece, it's really critical for our business. And then obviously the initial transmission cleaning, going back to that foundational principles, it's called Jasper Clean is what we call it around here. We're going above and beyond what our competition would do and making sure we're bringing this product in for that foundational piece on the cleaning. Now we're going to go over to the converter department and back with Luke.
As we said before, every unit gets split from the converter. That converter comes here to the converter department. What we do here is the first thing we're going to do is we'll come through and we'll split that converter open. We want to inspect every component that is inside that unit. After we go through and we inspect that, we'll order any new parts that we need. We take all of our pistons that are in there. We peel off all of our old friction material and we'll rebond those pistons so that we've got fresh friction material in our converters. Then we'll go through and we'll do any of our lathe work, we'll do any of our sanding, any of our polishing that we need to do to ensure that everything is back up to OE spec or more. We'll also go through and we'll make sure every converter is balanced before it leaves here, and then we'll put a fresh coat of paint on that converter before it goes out of this department and meets back up with the transmission in the pod. We're here in our case prep area. So whenever a pod tears down a unit, they'll send the case back to this area so that it can be inspected, and we'll do any of our sanding. We'll fix any bolt holes that we need to. We'll ensure that there's no cracks in that case, and that's all run through here. We also have our own welding area where we do our welding internally here. Once they're done with that case, it will then filter back out to the pod to that final assembly position, and it meets back up with all the other components to where it gets built. Hey, this is our solenoid area. So with more and more units having solenoids and TECMs, that's a big part of our remanufacturing process. So whenever those solenoids and TECMs come through, we send them out to a separate area so that all of those are tested, any repairs are done, and we run them through our tests that we've designed to check all of the shift points on those solenoids to ensure that whenever it does get mated back up with the unit, it operates in its proper way.
All right, thank you, Luke. I'm going to touch a little bit more on the solenoid cleaning and testing piece there, and especially on the TECMs, with the transmission today, with the TECMs internally and a lot of the flashing and programming that's going on out there, this becomes really critical to the quality of our product. So we're going to continue to see this area of transmission remanufacturing grow, and we're continuing to bring some quality folks into that division. When you're looking at, again, chip issues across the world, and we really see this playing through and deep into 2023, the aftermarket is going to continue to thrive because of that. And it's really based on these solenoids and different things like that. So anything we can do internally and not rely on another vendor for, it's going to help us out tremendously to get that product out to you all sooner. So that is an area that we're going to continue to grow. Okay, we'll go over to the pod remanufacturing piece and follow through with the dyno testing.
Hey guys, we're now here in the pod. This is kind of where everything comes together and all the magic happens. I've got one of our group leaders, Mark Ernie, here, who's going to explain the pod process.
Hello, welcome to our transmission pod. This is where the remanufacturing process happens. It starts off with our disassembly position. Disassembly is a very critical start to our remanufacturing process. We have all the correct tool and processes in place to make sure no parts are damaged during this process. It's also where we spend a lot of time on cleaning and detailing parts and putting them in our JRI washers. Once they go through our washing process, it gets to our inspection stage. The inspection is broken down by product group, and it's all on a unique identification on a tag number. Once we scan these into the computer, pulls up our bill of materials, and again, it goes step by step for our inspectors to make sure they meet our specs, criteria, all the critical components of what goes into that transmission. From inspection, it'll go to a valve body and pump disassembly station. Again, just like our transmission disassembly process, that's where we make sure we tear down the parts correctly. The pump and valve body get assembled, cleaned. We do vacuum testing. We do flatness checks to make sure our pump gears fit and all align. And once the pump and valve body assembly are built, they'll go to our sub-assembly station where all the parts come together for the transmission to be built again. The sub-assembly station as well does clutch clearance checks. They'll make sure to put all the seals together, pretty much build all the subcomponents for final assembly. The final assembly station is where we obviously put the unit back together. That's where your internal parts are assembled into the case. We do an anthromatic test at that station, make sure the hydraulic system is good and there's no cut seals. And once the torque converter is remanufactured, we'll install it at final assembly and get it ready for the dyno.
Now we're standing in a megapod, very similar to our other pods, but on a much larger scale. Our units that we're producing quite a few a day, we look to run to a megapod stance, mainly because it allows us to spread out those positions and we can allow smaller, shorter tacks, so it's easier to train our individuals and it makes things flow a lot smoother. So just like the other pod, we've got our disassembly, we've got our sub-assembly area, we've got our inspection area, and we've got final assembly. We also include our case prep area into this group as well. And you'll see, it's hard to see on the video, but it's much, much larger and it takes up much more space, but it flows a lot quicker to where our tacks are very, very short. So it allows us to train people very fast so that we can push more units through this pod. After a unit is built within the pod, we attach our converter to it and then we send it to our dyno to be live run tested. So every unit that we build here in this building is tested on our dyno. That dyno is checking for many things, but it's checking all of the different shift patterns. It's making sure that we've got proper pressures, and it goes through the entire dynamometer test to ensure that whenever it leaves here, it's going to work for you guys out there in the field. This is our custom and authentic area. Our custom area is one that we bring a unit in and a customer wants it a certain way. They want it their way. So we bring it through here and we've got one person that's doing the disassembly all the way through the inspection and the final assembly of that unit. The other is an authentic. So that is a unit that somebody wants to bring in that we don't sell, but it's something that we have the capability of building. So we'll bring that through, and a lot of that's for your classic car market, but we'll bring it through. And if it's an item where we need to do numbers matching, we can do that. We can document the build process. We make sure that we keep the case the same, any of those components the same. If they want it Ford blue or Chevy red, we can do that as well. So that's what we do here in this department. Here in our shipping department, that unit will come to us having already been tested at the dyno. When we run it through our shipping area, we will drain that unit. We'll drain the converter. So we'll pull the converter off. We'll make sure that it is fully drained out. And then we do something that's pretty unique here at Jasper is we dunk tank test every unit that comes through our area. So we'll actually pressurize that unit and we'll dunk it into water and we'll check for any bubbles. As you know, cracks are an inherent issue that we run into. So having that dunk tank test allows that any hairline cracks that could be in that case are caught here in shipping. After it goes through that area, we'll get a fresh coat of paint on the outside of that transmission. We'll add in any of our stickers, our warranty paperwork that we need to, and then we'll put it in a skid, bag it up, and we'll send it down to Crawford County.
Okay, thank you, Luke. A couple things I want to reiterate there on the mega pod he was talking about and the tack times and the quality that we're getting out of that. Some of our higher volume transmissions right now, like the 6L80s, 6L90s, we're obviously going through those mega pods, but we're also able to do training there and get somebody up to speed much quicker. You saw Luke talk about how spread apart it is. And again, all that is part of our lean process that we started many years ago. And Power Drive, the facility that you were seeing there, that's where all of our transmissions are remanufactured, about 80% of our transmissions right now. And we're continuing to work to get the remaining 20% there. So all of it's isolated in that building and we can focus on the quality of those transmissions. You saw the tool boards. There's been a couple questions on the tool boards. That's been set up for lean as well, ergonomically correct for the height of the individual that's working that particular pod. And again, it's all about safety and keeping our folks safe and able to work. Question came up on, do our converters stay with the transmission? No. We're not able to do that. However, obviously we're matching the proper converter with the transmission based on stall or whatever the valve body requires as well. So, but you saw that process where we're cutting them open, we're getting involved in there with the stator and really taking a full look of that converter. Over the years, we had purchased converters from outside, we brought it inside, we've gone outside. We've had it internal for many years now. And again, it's all about keeping that quality in-house and having that quality control in our own product. We are going to move over to our diesel division with Ryan Dooley.
I'm staying in pod 70 assembly where we produce all of our 6-liter, 6.4 Duramaxes, 6.5s, and 7.3 Power Stroke engines. We're talking about built-in quality checks and the different things that we do to ensure the product is built correctly. Something as simple as paint marking. You notice on the engine, the operator has taken a paint mark and dabbed the bolt. That is verifying to him that he's checked the torque on that. You'll notice on head bolts, there'll be a line straight across that. When the operator's finished, he'll look, the line should be here, but the bolt head should be turned. That is our way of verifying that each bolt is torqued and installed correctly. Another way that we do is the way we install our rear main seals on Duramaxes. We actually use a driver to install it. Once it's installed, we take a runout gauge and rotate the engine, checking for runout to make sure that seal is installed correctly. Next stop on the tour is Pod 80. Pod 80 builds all of our 6.7 Scorpion and all of our international inline engines, along with a variety of custom 8.2, 3208, 4HK1, and oddball Detroit applications. Again, due to size and space restraints, we had to get creative with how we convey the engine through the pod from station to station. Behind me is Station 2, where they've actually laid the crank and they're getting ready to stuff the pistons. You'll notice the workstation is also a floating workstation, but it's on a caboose or a train car. Instead of the traditional U-style pod, this is in an L, where it starts over here, comes through on a cart. When this operator's finished with his position, it'll float down here to the next station like so. Next stop on our tour is Pod 90, where we build all of our Cummins ISB 6.7 and 5.9 engines, also the Caterpillar 3126 and C7. Obviously, diesel engines are heavier and much more difficult to produce than gas engines. In the gas engine area, you see conveyor that runs. That was not feasible on the diesel side. We had to get creative. Due to floor space restraints and the fact we didn't want anybody getting hurt trying to push an engine, we come up with a floating workstation. Engine block gets dropped on. Associate will plug in air power to it, and this will actually convey and roll over to the next station. At that station, the operator can perform his necessary task, laying the crank, stuffing the pistons, dropping the camshaft in. When he's finished, it will then convey on and slide over to the next workstation. This technology is so easy. It has prevented all kinds of injuries, and it floats through the system effortlessly.
Thank you, Ryan. So on those 3 pods, you saw a lot of different things going on, but one thing I want to focus on are the floating workstations that Ryan talked about. And many of you that have come out here, you come out here once, maybe 10 years later, you came out and you're just amazed at all the changes. And really where that comes from is our continuous improvement program. All of our associates, depending on the level that they're at, are required to provide a certain number per year. And that's where the ideas come from. It's about safety, truly overall. And again, that's going to save all of us money. And as an ESOP, an associate owned company, we take a lot of pride in that, and therefore continue to keep a competitive product priced right for the market. So appreciate Ryan talking about the workstations and kind of everything that went into that, but that comes from that continuous improvement ideas. All right, we'll go back to Ryan and go into some testing.
I'm standing outside of our diesel spin room where we actually will calibrate and test all of our complete engines that we produce. Again, the complete is the long block with the oil pan and front cover. Over my shoulder here is the spin stand where he's going to hook it up, add water and oil. It's going to run for 3 minutes, getting the oil up to temperature and making sure that there's no bubbles in the cooling system. When it's ready, he'll go through and check compression on every cylinder. It's green or red. If it's red, it gets rejected. He sounds the andon, and the team leader from that pod will have to come up and figure out what's wrong. If it's green, that means it passes and everything's correct. We're also checking for oil leaks. We're checking for proper oil pressure. Just like on the diesel dynos, there's dye in the oil, and they'll actually go in and black light test to verify that the engine is leak free. I'm at the diesel dyno standing here with Cam Burkle. Cam is the group leader of our dyno. Cam, can you share with us some of the built-in quality checks that we use when we're dyno testing our engines?
It's a great question, Ryan. So we have multiple built-in quality steps we have to get the engine dyno tested before it leaves the building. A couple of those are we have a 2-part system where we run the engine at 2 different intervals on horsepower and RPM ratings. We also, in between those, on startup and in each one of those runs, we do different checks. We're checking for no water leaks and no oil leaks. We use a dyed oil to verify that we have no oil leaks. We shut the lights off in the room and use a dyed oil. And also on those runs, we use a OE equivalent test setup to verify that the engine's performing as it should. We also, at the end of the run, verify that it will pull horsepower. So through all those multitude of steps, we verify that we're sending out the perfect product to the customer.
Are we checking for trouble codes and engine performance as far as balance rates on injectors at all?
Yes, we check multiple different times. We check in the beginning when we first start the engine. We do a buzz test as well as an engine code check when we first start the engine, as well as before the engine leaves.
What about smoke and blow-by? Is that checked at all?
Yes, we have opacity meters in each dyno. We're checking for those. We also do a blow-by test on every engine. We make sure that they fall well under the parameters.
Thank you, Ryan. And I think most of you know by now, we're all about testing and testing the product before it gets to you. I mean, really, when you look at the diesel product, many of those are in there 3-4+ hours running with all those additional tests that we have to do. And with the technology today, with the injectors and the ECNs, TCNs all wrapped around that stuff, I tell you, it's a blessing we're able to do that before it gets out to you all. You know, just installing these engines, sometimes there still has to be setup time for it and a programming piece of it. You know, I was laughing at Cameron. Ryan was kind of digging them there and testing them on everything we're testing in that product. But you can see in the background, the computer screen and everything's there for the associate to see. And again, the red pieces are going to come up. What's not passing, green's passing. And again, take some of that human error out of it. But we're still going back with the basics, with the lights to make sure there's no leaks and different things like that. So they do a great job there. All right, let's go back to Ryan and look at our fuel components.
Next stop on our tour is our diesel fuel room. All of our injection pumps are remanufactured in this facility. We are a Bosch service dealer, which means we follow all the latest test equipment processes, all the latest tooling, and also Bosch OE certified components when we're remanufacturing those pumps. Whether it be a Bosch inline pump or a CP3 high pressure fuel pump or a VP44 injection pump, all that information is performed here. We also remanufacture all the Detroit blowers and governors, 3208 CAT injection pumps, and all the other miscellaneous fuel system things that go out the door from this area. You'll see the workstations are concise and defined for the work that's being performed. When we did the workshop efforts in here, we were able to reduce the footprint and improve our efficiency. Some of the built-in quality steps that we have are parts presentation boards. After the inspection is done on the product, the associate can place those components in said location. That way, when the builder gets ready to build it, it's proactive manufacturing. He has all those components, doesn't have to stop and leave his workstation to pick up parts. We offer a wide variety of diesel fuel injectors with our over-the-counter program. The biggest seller we have is the 6-liter injector. We also move quite a few 6.4 injectors, and we can't forget the Duramax. That whole product bandwidth, we've got product offerings for those as well. Also in our product offerings are contamination kits. What's in the kit? The pump, the injectors, both rails, the sensors, the return lines, everything you need to install and get rid of that issue that you've had with contamination, whether it be in your fuel system or a pump failure that's taken out the entire setup. Also included in our product offering with our retail program is cylinder heads. We offer light duty and medium duty cylinder heads for all diesel applications. Biggest mover obviously is the 6-liter and 6.4. Those are still the most popular applications out on the road. We also sell the Duramax. The entire Cummins family from 6B to 5.9 to 6.7 Cummins. And there's also a variety of passenger car gas heads from the Hemi to the Gen 3, 4, 5 Chevy head. I'm sitting in our diesel fuel room calibration room where we calibrate all of our fuel pumps. Behind me are twin 815 Bosch test stands. This machine right now has a Bosch VP44 pump on it. As you can see, there's no operator behind me. The machine actually does the calibration for you. He's got a monitor in the other room where he's building the pump, and he can actually keep an eye to make sure it's doing all the things it's supposed to. The machine's going to go through the process of calibrating the pump. Once it's finished, it's going to flash the PSG so it's calibrated and ready to go. Customer gets the pump, he plugs it in, it's a plug and play setup. I'm in our diesel turbo room. Here, all of our diesel turbos are remanufactured to the latest and greatest OE specifications. After the turbo is disassembled and fully cleaned and ready for production, it'll be brought into our assembly area. First stage, the associate's going to go through and verify all the parts are correct. They are what they're supposed to be. And then he's going to do critical to quality checks to make sure the turbine shaft is in spec, compressor wheel, and all the other various items meet our criteria. After the center section is assembled, we actually will dyno test the center section using our high-speed core balancer. You notice behind me, there's a high-speed core balancer along with a recovery tank. The burst of air that machine requires to function is 150 PSI. So in the event he finds a problem and hits reset, we're not going to drain the tanks out on the shop floor. We can continue to build product out there. This machine itself is going to dyno test it to make sure the first operator balanced it correctly, and then to make sure the second operator assembled the product correctly.
Thank you, Ryan. Quite a bit of information there. On the over-the-counter heads he was discussing on the gas and the diesel side, I'm so surprised how many people are unaware that we're selling them over the counter, and we're continuing to see that division grow. I think each month we're beating the previous month's sales. And again, when you look at a hard-to-find product right now, replacing a head could get a customer back on the road. So keep us in mind on that. In the fuel pump calibration, love going in that room, and the testing equipment there is amazing. You saw the huge air tank and the 150 PSI that Ryan mentioned there. Again, truly be able to do that testing there is going to make sure you get that quality product. We do get questions a lot on reman versus new, and we are selling new turbos and remanufactured turbos. Most recently, most of you know, we acquired another fuel and air company, D&W, and that adds to our Jasper Holdings brand of with Diesel USA, Weller Truck Parts, and JIS. So we truly have a great breadth of product now under this Holdings brand. We did get a question come in on the L-shaped processing piece that you saw Ryan talk about on the diesel side. And that truly is for the higher volume families. Not every diesel engine is set up in that L-shaped piece. And then as far as our associates, they are all cross-trained because if we missing somebody or whatnot, you got to be able to step in and do another job. They do have their main piece of that manufacturing process, but again, they're cross-trained. We also have what you call a bench player, if you will, that can step in if we get a little lean on that. So great question. All right, we're going to jump over to our differential division and have Tom Ireland take care of that.
Our differentials start with our disassembly process where we disassemble all of the small parts, dehair, and from there we're going to move into our cleaning processes. We start with a Agilift tank where we're going to put these through a very effective chemical that's going to remove all of the road grime and dirt from the housing. Going to get that clean. From there we're going to put it into a shot peener where we use steel shot just to get a little bit cleaner on those housings to prepare it for our inspection station, which is the next step in our process. Our next step in the cleaning process is our buffing booth, where we're going to spend a little more detail on our housing, getting any leftover residue that was not able to come off in our shot peen process. We're going to get our gasket seals off and get our bolt holes clean and prepare our housing for the next step in the process, which is our inspection. The next step in our process is the inspection process, and it's actually a twofold process where we're inspecting all of the bolt holes for threads. We're inspecting all of our seal surfaces to make sure that they meet our specifications for the assembly process. We also then straighten all of our housings. So we're checking for straightness, making sure that the caps fit, making sure that all our housings are straight, and then we straighten as needed using a hydraulic press to straighten those housings 100% of the time. Here we are at the next step in our process. So after inspection, any housing that does not meet our straightness criteria or spec will come into our machining area. Any housing that comes into our machining area is 100% checked for straightness and straightened accordingly. 100% of our full float housings will come into our machining area. They are checked for straightness. We do check spindle end per the OE manufacturer specs. Any spindle end that does not meet those specs, we will machine those. We machine those several ways. One way is we'll weld those up, whatever seal surface that we need to weld, and then we will cut those back down to our specs. We do also replace some spindle ends 100% of the time based on those measurements, and we will then machine those the same way we do our others, where we'll weld and then cut those back down to those specs. One other process that we do in our machining area is our vertical mill, where we are checking all of our pinion surfaces, pinion seal areas, as well as our outer seal areas to make sure that they are to spec. If they are not, we will put those on the vertical mill and we will machine those or sleeve them to make them in our specs. We also do all fronts differentials and their ball joints as well. We will machine those to the OE spec.
So always enjoy this part of it, because with the differentials, a lot of people don't realize how much machining truly goes in to put out a quality product with that 3-year warranty on it. We see a lot of folks, probably many of you, to set up that ring and pinion and with all the different spacers and everything like that. Really, when we get these in, about 60% of them are bent and they need to be straightened out. Now, it's not to say that bend is going to cause a failure, but it is going to cause some wear and tear on those internal components. So that straightening process is something that really brings a lot of quality into the product for us. All right, we're going to jump over to the internal components and assemblies.
After our differential is initially disassembled at the very first process that we looked at, the parts from inside the hog head will actually go into a different process where they come to our disassembly 2 station, where we now disassemble the ring and pinion, we separate the case out, and we start the cleaning process for all of our small parts that are inside of the differential. We do also remanufacture all of our own lockers here in the differential division. So all of our electric lockers, standard lockers, our limited slips, we remanufacture all of those. We process those just like all those parts from inside the differential. We're going to clean those. We're going to blast them. We're then going to wash and then reassemble those back to OE specifications. Final step of our small parts processing process is the inspection. So after the parts have been washed and cleaned, We then have an inspector that will go through each of those parts, paying close attention to the ring and pinion, looking at the teeth, making sure there's no abnormal wear, chipping, anything that could potentially cause a defect in the final product. We'll then process those, and we do try to use used ring and pinions and salvage as much as we can, but the inspector is very diligent to make sure that we have no issues with those. We're now going to show you the final assembly stage of our process, and to explain in a little more detail all the steps that we take is Angelo Bravo.
Like Tom said, some of the steps we check for quality are tooth contact pattern, backlash, and variation. Tooth contact pattern, the builders are looking for a centralized pattern. Backlash, we check in 4 different spots. We go by OEM specs. And variation, we'll check it when we check the backlash. And we're just looking for a little wobble in the gear or case. And those are the steps that we take to ensure we build a perfect product.
So again, it's all about testing and tooth contact, backlash. Everybody's heard those terms before, but something, again, that we follow through with. And then he talked about we do remand the ring and pinion. Again, many of them are new, but we are going to go through there. If it comes back to that OE spec or better, it is a product we can remanufacture. Something else I wanted to mention, you've probably seen throughout the tour, the clocks, some of the digital clocks up there, and that's what we call a tack time. You've heard it mentioned by several of the associates, and truly that is, again, talking about lean, how long a particular process should take before it goes to the next one. Over at Power Drive, we've actually got parts runners running around on the carts that are going to pull up at a certain time each day, throughout the day, I'm sorry, when that product is being built, and it's making sure everybody's following that tack time. So we've got budgeted to build 35 particular transmissions a day. That's to make sure we're able to do that. Now, obviously, the parts need to be in place, and labor needs to be there for that to happen. And that's why we have the tack time. So I've seen several questions in the past on that. I wanted to bring that up. Okay, we're going to wrap it up with our transfer cases.
So a somewhat new addition to our differential division that I would like to call out is our transfer case, a pod that we have been working with for about 2 years now and are starting to develop, put some new products in. So very similar to differential on a much smaller scale. Our transfer case runs through a disassembly process. We clean the parts, inspect those just like we would in differential, and then go into the final assembly process. And again, keeping everything to our Jasper specifications to make sure that we build a very good product that will last a very long time for our customers. So we do want to call out our transfer case pod, and looking forward to seeing what this pod will bring to our differential families.
Okay, thank you, Tom. So that wraps up the virtual tour piece of the manufacturing process. Again, if you all could give us feedback on how today went, the virtual piece of this, we want to continue to do these, and we are going to start doing physical tours again. We're some time away from the type of volume of tours we used to bring in here, but we do want to start to get folks back out here to see our people and what we're bringing new to the market. So in the chat section, if you could provide feedback to your sales rep. So what can we do differently as we start to do these virtual tours more often? And how can we make it better for you? And then not only that, truly what Jasper can be doing differently in the market right now. And again, as I shared at the beginning of this, the things that we're doing behind the scenes to get product in here, get parts in here, and get product back out to you on a timely basis. We're doing that the best way we can. When you look at inventory, there is no inventory. We're out of inventory. When you look at April or I'm sorry, May, June of 2020 and coming out of that COVID piece, it really went from 0 to 100 miles an hour, as you all have experienced as well. So we're truly blessed to be in this industry and at the type of volume that we're experiencing right now. So thank you, everyone, for being here. We know your time is very valuable. If there's a different time we should be doing these, please share that as well. So again, on behalf of the 2,300 associates at Jasper Engines and Transmissions, thank you very much.